Today we're going to talk about transformations. Good news on these transformations is they behave very much like all the transformations we've done in the past, whether it be quadratic or radical. The things we need to talk about, anything that happens inside of a parentheses. Remember, if we're dealing with stuff inside parentheses, we have some kind of a vertical transformation. The same thing is going to be true about our exponentials, and it's going to be true about our logarithms as well. And anything that happens outside the parentheses is horizontal. Is a horizontal movement. We're going to first start talking with the exponentials. We'll highlight these things. The first thing I want you to recognize on the exponentials is the base is the base. The part that is attached to the exponent that has a variable in it, that is our base. All that does is decides what family of functions we're dealing with. Make sure you don't try to make that part of the transformation. That's probably the most common mistake. But what we need to recognize is if we have a base of 2, we are in a doubling family. If we have a base of 1/3, we have a decaying family. It's decreasing, and it is a base of 1/3 though. So that's our first stumbling block right there. But we can recognize, hopefully we can recognize a lot of these things from when we dealt before. Now you'll notice I have both the logarithm family and the base family because these notes we're going to put below are all the same thing. When we have an a value, a value that's either in front of the log or in front of the base with multiplication, it is outside of parentheses, which makes it a vertical. And because it is multiplication, not addition, it is a stretch / compression. And the difference between these two is the number. Remember, if the number is a fractional number, is a number between 0 and 1, it is a shrink, excuse me. Anything else is a stretch. So that's what our first element is. The next thing we're going to take a look at is the C value. Now in both cases of these notes, hopefully you've got these down, in both cases of these notes, the C is happening inside of a parentheses, which means it is a horizontal movement, and since it is adding or subtracting, it is a shift. So this is a horizontal shift. Next thing we need to recognize is D, and remember with the horizontal shifts, if you want to put a note to yourself, put a little star there. Remember, anything that happens as horizontal always has that inverse behavior. Next thing we see is D, which is happening outside of a parentheses, which makes it vertical. And it is also adding or subtracting, which makes it a shift. And then the last thing we're going to talk about, it doesn't have its own letter, but we need to recognize and remember this, that anytime we tack a negative sign somewhere, any negative results in a reflection. Negative signs result in a reflection. Excuse me. If that negative sign is inside of a parentheses, it's horizontal. If it's outside of a parentheses, it is vertical. So we'll take a look at a few of these examples, and hopefully after you see a few of these, you'll be reminded of the transformations we did in the past, and you'll be able to move pretty seamlessly through these. First thing we're going to do is just take a look at some of these functions and see what we have here. For instance, number 7, we have a function that has a 3 in front of the EX. Well, that is not a shift because there's no plus sign, so it hasn't moved from its normal spot. And remember some normal things we do. We asymptote on the x-axis, and we have to cross through the point 0, 1. Well, we should be crossing through the point 0, 1, but we've tripled all of our numbers. So our answer D is the one that matches this. You notice it is asymptoting where it's supposed to, and instead of crossing through 0, 1, like we're expecting it to, it's crossing at 3. And the purpose for that was the 3 that's inside. So we had a vertical stretch. That's why this graph has been stretched up to reach to the sky 3 times faster than it normally does. Looking at question number 8, what we recognize, hopefully, is that it is a negative, which is a reflection. So instead of coming from the top, this one's going to be coming from the bottom. And we also see that it has a base value, or a value in front, and a value of 0.4. So that is a shrink. That is a shrinking amount there. So we are both going to reach towards the negative, and this is also going to shrink. This answer would be B. And here's why I wanted you guys to, why we put so much emphasis on the 0, 1. Well, when it got reflected, it started facing down. Well, that would have put it at 0, -1. But since we have compressed this thing, we can clearly see that it is not crossing at -1, it's crossing at -0.4. So that would be our value there. This one was D, this value is B. Number 9, the only thing that's happened is we have the Euler's number function that's been shifted up 2 units. So where it normally rested on the x-axis and crossed through 0, 1, now it's resting on the value of 2 because it's been shifted up 2 units. And instead of going to 0, 1, it's now at 0, 3 because we have shifted it up 2 units. So this one would be A. The only one left would be C, but let's talk about why it is what it is. It has the negative number in front, so it's a vertical flip. That's what negative signs do. They flip this one. So that's why this one is now shooting towards underground as opposed to in the sky. We also notice it is crossing through 0, -1 instead of 0, 1 because we have turned those values to the opposite values. We're going to follow these instructions except for the part that says graph. We can use our calculator to do this. The main thing I want to do is identify what has happened to the function and then also state the asymptote. So this function has a base of 2. So its traditional place to asymptote is going to be at the x-axis. So it's accustomed to doing this. It's accustomed to crossing through 0, 1. But we'll see how these transformations go. So the first thing we have is the parent function. I kind of gave you a rough draft of that, but that's okay. So here's what we have happening on g of x. We have a change inside of a parentheses, which makes it a horizontal movement. And that horizontal movement involves a adding or subtracting. Anytime we have that, we have a shift. So we have a horizontal shift happening here. So what it is now is a matter of, do we recognize what's supposed to happen? Well, -3, our mind wants to tell us, okay, we're going to move this over 3 times to the left. But remember, anything that happens inside of a parentheses has the inverse effect. So instead of moving left 3, we're going to move right 3. So my suggestion is go back to that point 0, 1 and just simply move it over 1, 2, 3 times. So now we will be sitting at 3, 1. This graph is going to now asymptote a little later, and it's going to do the same thing. So this is a horizontal shift right 3 units. We actually have not changed the asymptote because the asymptote is still at the x-axis, excuse me. All right, let's take a look at the next one. Still part of the 2 family. Remember, that has nothing to do with a transformation. We have the +3, which is horizontal. because it's inside of parentheses. It's shift because it's adding or subtracting, and it's left 2 because we always do the inverse. So let's identify the other transformation. The other transformation is happening outside of a parentheses, which makes it vertical. It is adding or subtracting, which makes it a shift. And there are no tricks on these. This one is just simply going to go up 4 units. Now, when we move this thing up 4 units, we will have first, going back to the green line, moved it back 2 units, 1, 2, and we would have moved it up 4 units, 1, 2, 3, 4. So that point would be there, and our asymptote would be 4 units higher. So we would now be asymptoting not at the x-axis, like we have been doing, but we will now be asymptoting at the y equal to 4. So we have made a change on our asymptote. For time's sake, we're just going to, again, identify the transformations. There's really no difference at all. We chose to use the number 10 because it's in the scientific notation so often that we might as well talk about it. So let's just talk about what g of x is doing. Well, g of x has a change inside of a parentheses, what that makes horizontal. That change is adding or subtracting, which makes it a shift. And anything that's happening horizontal is the inverse of what you think. So this is going to be a horizontal shift, right 1 unit. And what I do, you don't have to do it my way. You're welcome to graph and find some ordered pairs. But I just think about that point 0, 1. Now it's been shifted to the right 1 unit. So instead of being at 0, 1, it's going to be at 1, 1. My asymptote will see no change, so we are done with that one. H of x. Something's happening inside of a parentheses, horizontal. That something is adding or subtracting, that's a shift. And we always do the inverse. So plus 3 feels like you should be going right 3, but you're in fact going left 3. And then the last one, the one that's really the easiest one, anytime we just go to the back and add or subtract, it's a vertical shift. And there is no inverses. Minus 2 makes you think down 2. Well, that's what it is. That is a shift down 2 units. So this is another exponential transformation. And if these feel vaguely familiar, hopefully they feel very familiar, but if they feel vaguely familiar, because we've dealt with this type of behavior with other functions. Now it's the logarithm's turn. Now here I can't emphasize this enough. This is what gets people a lot. I chose to use the log base 2 family on this, and everything else beyond that is a transformation. What we need to remember on this is our inverses are also, this is an inverse function, is going to have an inverse domain and range. So when we had the exponential, the domain was all real numbers, where in this one we're going to have a range of all real numbers. And what we have in this place is an asymptote that is on the y-axis, which is a vertical asymptote. All right, so let's talk about this function real quick. It is the same function. Parent function log base 2, but what we are doing is we are shifting it up 4 units. Something's happening outside of a parentheses, which makes it vertical. That something is adding or subtracting, which makes it a shift. And we do exactly what it says, so that's going to be up 4. So if you just simply slide and you think about what a logarithm function looks like, is this general shape right here. And remember, that one goes through 1, 0, and then it's going this way. So if I shift this thing up vertically 4 units, I'm still going to have the same asymptote at x equal to 0. So this is simply where we would stop this one. This log base right here, we have something happening inside of a parentheses, which makes it horizontal. That something is adding or subtracting, which makes it a shift. And remember, it's always that reverse behavior. So -3 feels like left, but it's actually right 3 units. So now this has affected an asymptote. Remember, we had an asymptote at x equal to 0, but we have just decided we're moving this thing over 1, 2, 3 units. So when I move this thing over 3 units, I've affected the asymptote. It's now going to be, instead of asymptoting at 0, it's now going to asymptote at 3. So we'll do like that. Smart move to do. I should have done this, and I'm going to now, is just move that 0.10. Move that 0.10 over 3 units. So instead of sitting there, it's sitting over 1, 2, 3. So now that's a better picture of what that graph is supposed to look like. All right, and then the last one on this particular section, we've got a couple of things going on. We've got something happening outside of a parentheses, which makes it vertical. That something is not adding or subtracting this time, so it's not a shift. So it is a stretch. And I know that it's a stretch because the number is higher than 1. So what we have is a vertical stretch. The way we state that is by a factor of 3. So that takes care of the 3 in the front, but we have something else going on here, and that is a -2. I don't see any parentheses, so therefore it's not horizontal, meaning that it is vertical. It is adding or subtracting, which makes it a shift, and it's actually going to go down 2 units. So this is how we transform our logarithms. I chose to show you this one only because this is what's called the common log. You'll see this from science all the time because science uses base 10 all the time. It's called the scientific notation. Well, the offset to that would be log base 10. Well, log base 10 happens so much that they gave it its own denotation, and that is just simply common log is what it's called. So when you don't see a number down here in the base, so if I have this, a number not down there in the subscript, that number is an understood 10. And again, this is all about science. 10 is such a common base that we've created the common log is what it's called to offset this. So if I wanted to come in here, I could come in here and squeeze a 10 in for each of those. But if I'm doing that, I'm doing it for me because my calculator does not care. It knows what common log is. It has its own button. Just look right by natural log, and there it is, right above it. Right above natural log is log. So this is the common log we have going right here on letter A. We've got manipulations outside of a parentheses, which makes it vertical. That manipulation is adding or subtracting, so it's a vertical shift, and it is up 6 units. Next one we see, we have a transformation, again, outside of parentheses, which makes it vertical. That is not adding or subtracting, so it's not a shift, therefore it's a stretch. or a compression. And in this case, since our number is between 0 and 1, this is actually a compression. And then the same way, by a factor of 1/3. And then the last one, the common log, x plus 1 minus 5. Well, what's happening here? What's happening here is inside of parentheses, which makes it horizontal. It's adding or subtracting, which makes it a shift. And it always does the inverse. So plus 1 makes me think right 1, but we're actually going to go left 1 unit. And then the 5 is happening outside of parentheses. That's vertical. It is adding or subtracting, which makes it a shift. And it is going to go down 5 units. So this is our common log. Nothing special. It's just the base 10, log base 10. If you were to put log base 10 in your calculator, it would work out just fine, but it's kind of silly to do that because this has its own button. Save you some time. Again, for time purposes here, we are just going to identify the transformations here. We'll take a look at these. We have Euler's numbers being transformed. Well, remember, Euler's number is really just a base of 2.71, whatever it is. And also remember that Euler's number is second and natural log. So if we put in second and natural log, we can look at this. I'm putting in my calculator right now so I can graph this thing a little bit better. Got to find some values that actually work. One of them I know is 0, 1. Let's do this one in black. We also see at 1, it's 2.73. At 2, it's 7.3. So we're back off the screen. So this Euler's number function, and then it's asymptoting at the x-axis. So it looks like this. Well, my next transformation, I actually have 2 on this. We have a transformation. Both are happening outside of a parentheses. So we have 2 verticals. Just a matter of finding what we have. Well, let's take care of the 1/2 first of all. It's multiplication, so we know it's a vertical stretch, but in this case, it's a vertical compression because it is a number between 1 and 0. So it's a vertical compression by 1/2. So all of the values are going to be 1/2 of what they originally were. So 1/2 of 1 is really easy. It's just 1/2. So this value that was at 1 is now going to be at 1/2. This value that was at 2.73 is going to be about half. And then the value we saw at 2 is at 3.6. That's actually on the screen. And 3 is at 10, so it's off the screen. So you can see that this has been compressed. It's gotten pushed a little bit closer to the x-axis. Half as close. So it's going to look just like this. It's still got the same shape. We've just compressed it. And then the last thing we have is a negative sign. Remember, this is a reflection. And this is a vertical reflection. So all of my values, the one that's at 2 is now down here. The value that was here is now down here. The value here, got off of my graph a little bit here. That should be there, sorry. So now this function looks like the red one. Vertically compressed, and then and then compressed, and then reflected across the x-axis. All right, next one, we've got Euler's number here. Plot my 0.10 because that's an easy one to get. Got a bunch of weird numbers. One is the 2.73. So it does this. Now this one's a little easier because we have two shifts. One is horizontal. Even though you don't see a parentheses, it's understood. But that is a horizontal shift. And we also have a vertical shift on the other side, outside the parentheses. So we have a horizontal shift. -4 means right 4. +1 means up 1. So I'm going to just take this point for 1. It's going right 1, 2, 3, 4, and up 1. So we have changed our asymptote up 1 unit. It's going to run just like this. So this is what this function looks like. In this case, the domain's all real numbers. The range is now 1 to infinity. Because where we used to not could go below 0 since we shifted up, now we cannot go beyond 1. And we can't go without talking about the inverse to Euler's number, which is the natural log. I feel like these are the easiest one, but people sometimes have some struggles with these. Just follow the rules. We have two things happening, both of which are outside of a parentheses. So we have two vertical transformations. Let's move this one down here. Well, let's go ahead and take care of the negative sign. That's just a vertical reflection. Done. Well, we've got a 2 in front of a natural log, so that's a multiplication. Multiplications are stretches or compressions. This one is a stretch because the number is actually bigger than 1. So we have a vertical stretch by 2. And then letter C, it's natural log. Something's happening inside of the parentheses, so that's horizontal. Something is happening outside of the parentheses, that's vertical. Now it's just a matter of what we have. Adding and subtracting on both cases. So shift on both cases. Now it's just a matter of how far and in what direction. +2 means we're shifting left. 2 means we're going 2 units. And then the last one, we do what we're supposed to do. Vertical shift. This one is going down 5 units. So those are our transformations, transformation logarithms and exponentials. We'll be asked to do state the domain and ranges of these things, in which case I would suggest getting really good at looking at a table or a graph and understanding what domain and range means. Domain means how far left and right something goes. Range is how far up or down it goes. Domain, range. All right, good luck.